I want to kind of structure this in a few different phases. First of all, since we have some extra time, I thought we could talk about some really basics about HTML, something that I've wanted to be able to do before and we haven't had the time. After that, we'll talk a little bit about the HTML API specifically. And then I'd like us to move, and hopefully this will be the bulk of what we do today, move into a phase where you all are working on problems and we're discussing the challenges together. As a show of hands, who here has worked with the HTML API already? Wonderful. At least half the room. Who here has found something they wished they could do with the HTML API, but you don't think that it's possible to do it? One person? Two people? Okay. Well, I hope that I can present you challenges you haven't come across, because this workshop is intended to push what we can do with the HTML API, push what doesn't look from the documentation like it can do. I want to pause for a moment and mention a few specific people. Adam Zielinski here in the red shirt co-wrote, co-designed the HTML API. And John Searle in a gray shirt, tan shirt right next to him, has been maintaining the HTML API for a year and a half, something like that, and has been advancing it, particularly in terms of script contents and CSS. And Carlos here in the front in a white shirt works tangentially with the HTML API and interactivity API. So these three folks are all experts and will help us with the workshop if you have any questions. Well, let's get started. Have you ever wondered how we got HTML? It's a rather fascinating story. I feel like it's easier to communicate some of the challenges that led to HTML in this room than it is in my home country in the US, because in the United States, the bytes that we used to store and communicate text only had to convey 27 letters, uppercase, lowercase, numbers, and symbols. And I think everyone, well, maybe not everyone, but most people in this room at one point in their lives realized that the computer system didn't accurately convey a diacritic or a slant or a stroke or something that augmented the text. And in the 1980s, computers were largely storing text as 7 bits, which held 128 characters. And this is mostly because these computer systems were designed in the United States. Most systems that networked together were all using the same software and were all a proprietary network. And custom formats were shared between those only because they were running the same code. And so people started to realize, as we network our computers, we need an intelligible way to exchange documents, and that it should be something that people can type. Because again, at the time, largely, people had an editor that they were working with, and they were typing with their keyboard in that editor and saving that file, and maybe they were exchanging the file, but it was all plain text. And it was all not only plain text, but it was very much like a typewriter. The file on your computer looked a certain way because every character was the same width. The file spacing, the new lines, everything worked on the screen just the way like typing on a typewriter would print something out. So how do we start to communicate these documents back and forth when my computer shows United States or Latin characters and your computer shows Polish characters? This was actually a big deal in the beginning, and a bunch of people got together in a big standards and created what's called SGML. Anyone heard of SGML? This was actually a fun story you can go into later on, but basically IBM had developed a system for drawing text interfaces. And they had certain ways of indicating that this is a list of bullet points, and this is a paragraph of text, and this is, a header. And it was a very primitive system that involved, a tag character at the beginning of the line that said this is a heading, and then the rest of the line was a heading. And the difference between reading a text document and reading something from IBM's GML system was that the software would read that file, read those tags, and render it in a different way than it appears in the source document. And this worked for IBM because they had trained people working with custom software that they could use and validate and display and have feedback on to make sure that it all works. And the tags were, it was line oriented. The tags started the line, and it was literally like colon P would be a P tag. This eventually became the basis for the set of tags that made it into the first version of HTML and explains some of HTML's funny quirks. So SGML came around adopting this, but they decided instead of having these line-oriented things, we'll surround it with angle brackets, the name of the tag, and there'll be a closing tag. And we'll work on a way of communicating this structure in a way that is easy for humans to write. What I think is the most novel expression that turned into HTML is people were very, very concerned about the fact that we all want to have structured data in our documents. We want to be able to say this is that, and not have to kind of infer it from how it looks. But people were thinking at the time, if we have to force humans to write verbose syntax, if we require humans to make sure documents are all perfect, they're never going to put up with that. And if we make the text all funny and it doesn't exchange between different countries, people aren't going to put up with that. So there were all sorts of ideas built into SGML that took what was a burgeoning software industry, new compute power, and they said, what if we specify a grammar for documents and have the computer parse those documents and interpret them and lean on the power of the computer to reduce the amount of work a human has to write? This is much smaller than I thought it would be, so I apologize. Can maybe zoom in if we're lucky. This is kind of the top of an SGML document, and if you've worked with XML, you might recognize some of this. This is actually specifying a grammar or how the document structure looks. And these are defining the tags. And then this is an actual SGML document. And with SGML, the grammar tells us a P tag can be optionally closed. It's implicit from the grammar that when there's another P tag following an existing P tag, it starts a new paragraph. And this goes back to those roots as a line-oriented protocol. There's all sorts of quirky syntax in SGML. Like right here, we have a tag that instead of having the closing angle bracket is just like a slash and a slash. And this is equivalent to having a tag called read.on angle bracket, an angle bracket slash read.on. And SGML has this angle bracket slash angle bracket. You might recognize it as the HTML logo. And in SGML, this means whatever the most recent opened element is, close it. All sorts of syntax affordances to reduce the amount of work that it takes to write as a human and to remove syntax from your documents. And please don't get lost in the details. We're not teaching about SGML here. I only want to show the roots and the idea that this comes from a time where people were focused on making it possible for humans to write structured data. There's a third component to these documents, which was actually specifying the syntax. And it would specify the character encoding that the document used, and it would specify which characters within that encoding were used for the different syntax elements. And it's kind of funky, but in an HTML document, even though the tags have this angle bracket, they call it the default syntax. You could actually replace that with parentheses. You could replace that syntax with anything you want. And the thing we know as the ampersand character could be something else. Like you could actually make it, not that it existed at the time, but you could make it the Unicode symbol for like a tag, which is kind of wild. HTML was full of all these really cool ideas, and they thought, the power of the computer can make up for the challenges of human typing, much like AI is today. But it turned out to be way too complicated. I don't think there was ever an actual HTML tool that implemented the whole HTML specification. It was an expensive document that nobody, wanted to pay 100 euros to, well, I guess it wasn't euros at the time, pay 100 Swiss francs to get a copy of the spec. And everybody on these mailing lists on the internet, nobody could comprehend it, even if they had the spec. I bought a copy of the spec, and it doesn't look anything like specs today look like. It's really, really hard to read. So if we jump into the future at CERN, we have somebody, Tim Berners-Lee, who is trying to build a document sharing that actually works, that people actually use. And he looks at HTML at a conference, I think, is the story, and he was inspired by it. And he went home with what he saw from the conference, and I hope I'm not telling this story wrong. This story exists in some form, but some of the details may be wrong. He went home from the conference and said, I'm going to write something like this, that looks like this, that's very restricted. He said, we're going to throw away the grammar part because that's complicated and nobody understands the grammar. We're just going to focus on writing documents. And he wrote a little HTML parser. And that was the original HTML. There was no spec. It was just a program he wrote and he shared. And it used this concept of angle brackets and tags and attributes on tags. And instead of having all this character set, he said, what if we just standardize? There's no, an HTML document can have 10 character encodings in different parts of it. It's pretty wild. He said, let's just make everything one way, and that way is the way I do it. And here we are. I like to share this history because today there's a lot of misunderstandings about what is HTML, why does it operate the way it does, and what is its purpose. When I was younger, I kind of fell into this myth that HTML is loose and forgiving, and there's terrible malformed HTML everywhere. And actually, that's a misunderstanding of how things came to be. Because when we have li tags that have no closers, that's not a quirk in the original parser. That's how the system was designed. So there's ways we can write software and data formats that are designed for computers, and there's ways we can write software and data formats that are designed for people. HTML's legacy is designed for people, for actual humans who have to type keys. And I love this, that as we built an HTML parser in WordPress, learning about this story and learning about the meaning of it. To me, that enriches what I want to do with HTML in WordPress, because it seems like, okay, who cares about HTML? This is the last thing as a developer I really care about. But through the lens of exchanging structured documents that humans write, there's almost an unbounded potential for interoperability on the web, for reinterpreting content in new ways, for doing all sorts of integrations and all sorts of things that we've wanted for decades and never had the ability to do. Because I'm thinking less about this is a string and I'm trying to pull something out of the string, and I'm thinking more about what is the structure of this document, what is the meaning of that structure, and how can I make an authentic translation of that meaning in a different form. So for example, we get a lot of content on the web that's copied and pasted from one spot to another. You copy it out of Word and you paste it in to WordPress. Who's looked at that paste? Like, that is one gnarly, massive paste. So how do we think about drawing that in? We want to preserve formatting. We want to preserve links. We want to preserve italics. We want to preserve bold. We want to preserve lists. But we don't want all that junk. So when we think about HTML as this structured format that's a container for different information, rather than a string that we should be trying to find a particular space in and extracting some text, suddenly these transformations become very, very within reach. Now, I say quirks, and I just said a minute ago, these aren't quirks. These are the way the system is designed. But let's have some interactivity. When you think about handling HTML, what do you think is the danger zone? Just call out. You don't need to raise your hands. What trips up the code we write? Regular expressions. Well, why? Why does the regular expression fail? It's actually possible to parse XML with a regular expression because regular expressions can be really gnarly, like, like this. But it's not possible to parse HTML with regular expressions because even if the HTML tags are balanced, it may not be the right document. Has nobody ever had a bug in their HTML parsing where something showed up that they didn't expect? We'll just take a look at some of these. Everything on these next couple slides is valid HTML. At the top, we have the doc type tag, which is normative HTML that I think a lot of us don't think about when we think about parsing HTML because we rarely see it. Right below it is a comment. A lot of code we write is unaware of comments, which, by the way, a wild thing about comments and doc types is that they can have a greater than sign, a right angle bracket inside of them. So a lot of times we write code that says like start at the less than sign, end at the greater than sign, and that's a tag. Well, in the doc type case, that's not a tag. In the comment case, it's not a comment, and we might actually chop it off right here. And now the rest of the document is bad. And it's even worse because you can't jump into the middle of an HTML string and find the next tag. It's impossible to do reliably because you could think that you're ready to find the next tag, but if you're in the middle of an HTML attribute or in the middle of an HTML comment, you could have something that looks like a tag, but it's actually not a tag. We have custom elements that have a dash in their name. A lot of times we think, tags are an angle bracket and then A to Z repeated. But custom elements can contain dashes. Actually, custom elements have to contain dashes. And that's true for the closing tag. And then I think like often overlooked is the fact that we can have character references. And I have a collection, I call it my HTML Hall of Fame of big websites like Citibank's website or Slack's. When Slack comes in and says there was a new post on this blog or this website, and it contains these character references. It's like a really trivial problem to solve, but we just forget that they exist. And these are all normative HTML that can throw us off when we're parsing. But there's more than just normative HTML. there's actually invalid HTML, or so-called invalid HTML. I said that HTML parsing being loose is a myth because ever since 2008, every single text document is a valid HTML document, in the sense that the HTML parsers all agree how to handle every single error that could possibly exist in a document. So if you open an HTML document in any browser or anything that supports HTML according to its specification, every single way that you can think of that the document could be malformed will have the same result. And those errors are basically meaningless, because while they are errors, they're only really an error for the author of the document. As a parser of the document, there's a clear mapping from text in to structure out. We get XML processing instructions, which comes from XML, which appeared after HTML. You know, a lot of times we think HTML is like XML light, but XML came after HTML. And that in HTML, all of these actually turn into comments. When the parser hits some of this invalid syntax, it actually transforms it into an HTML comment in the browser. This is actually what an SGML parsing or processing instruction looks like. In XML, they're required to have a question mark at the end. But in SGML, they actually came without that. And they were there for things like next page, as people were trying to think about how can we represent paper documents in digital form. These were instructions given to the parser. So maybe an HTML browser would just ignore it. If you wanted to print your page, this was a hint that at this point you move on. One of my favorites are misunderstood self-closing tags, which HTML doesn't have. So actually, if you close an image tag like this, it's a benign error. This was a concept that came with XML after HTML had developed. And this goes back to SGML. In the SGML grammar, it has this concept of void elements, elements that can contain no content. So there was no need for the slash. I mentioned the HTML logo. This also exists, and it's special because if you open it in a browser, this disappears. It's completely ignored. You could stuff your HTML document with 1,000 of these, and nobody in the browser would ever see it. And then CData expressions are particularly something that I see a lot in WordPress code. CData sections don't exist in HTML. A CData section in XML is like, whatever this is, it doesn't need escaping. And in XML, it basically runs until you have a bracket, bracket, angle bracket. And the idea was like, for this span of the document, we're not going to interpret the text. We're not going to interpret character references. We're not going to interpret tags. But that doesn't exist in HTML. And it's kind of funny because the HTML rule is once you start one of these, it goes until the nearest angle bracket. So it'll actually parse differently than it parses in XML. And then we have all sorts of malformed character sequences. For example, you could have a document with 10 megabytes of zeros in front of the character reference, and it should still parse just fine. But a lot of code doesn't anticipate that, and it trips up. But it's not just about syntax. There's more quirks in HTML. A lot of times I hear people say, like, if we have balanced tags, we can parse HTML with a regular expression. In fact, WordPress has this function called, anybody know what function I'm going to say? Force balance tags. It tries to make every tag have an opening and a closing. But this is kind of funny because, as we mentioned before, p tags automatically close an open p tag. And there's even a weirder thing in HTML, which is that if you come across a p tag closer, and there's no open p tag, you know, most of the time when we come across a closing tag, it ignores it. But in the case of the p tag, it'll actually open a new p element and immediately close it, which can mess up the CSS if you change it. This one is fun. Everything inside of a table in HTML is required to be inside of a table cell. And if you get tags inside a table that aren't in a table cell, then when the browser loads it, it actually moves this div in front of the table. So you can have a big table with 100,000 rows, and at the very end, if you have content, it actually comes before those 100,000 rows and will display in front of the table. It's a very weird thing. Maybe someone has seen this quirk come through in WordPress or other websites. I see it in search results all the time. But the HTML title element cannot contain tags. Now, it looks like it contains an image, right? But if you were to render this web page, your browser would show in its bar at the top of the tab, bracket img bracket. Because inside the title element, this is just text. It'll interpret character references, but it won't interpret tags. And the same is true for the text area element, some deprecated elements, and I don't know what else. And this isn't all the quirks, but this one really gets me. This is balanced HTML. But who knows what's quirky about this last expression? You can't answer. Christoph. The H2 inside will do nothing. That's a good guess. Any other guesses? It's very close. Many of the discussions in 2008 leading up to HTML5, where all of these error conditions were formed, concentrated around this question: what happens, what should happen when we encounter a situation, because H elements can't nest. So actually, what is in this snippet of HTML is an H1 tag opener. There's an implicit H1 closing tag right here, and then an H2 opening tag, and the H2 closing tag, and then this is an unexpected H1 closing tag. So these that look nested are actually sibling elements, which is even more confusing if you look at the fact that there's an H group element that can group headings together. But I think this is all fun. Oh, look, I actually wrote out and forgot to put. This is how each of these transforms. When we think about building safe systems for working with HTML, which, by the way, is the language of the web. WordPress is a web server, web content management system. So we want to speak the language of the web. We think not only about properly understanding the language we're working with, but at least from WordPress's perspective, we have to also think about making that system safe by default. What can we do to ensure that other code that takes these shortcuts, that writes the regular expressions, will have a better chance of succeeding? And one way we do this is we think about this mapping from the shorthand format that a human might write or mess up writing, or which software might combine in weird ways and mess up, and how do we make that safer? And so the HTML API actually has a function called normalize. And what normalize does is it will take this on the left, and it will return the content on the right. And the whole purpose is to say, like, let's move kind of unexpected content in the system that's perfectly valid, perfectly legitimate HTML, and send it down the river in a way that more closely matches people's expectations. Because while all of us might look at these examples and come up with a different guess, if we look at these examples, there'll be no questions. This table one is interesting because a lot of us think about malformed HTML with like unclosed list items, but very few of us, I know I didn't used to think this way, very few of us think that a table with a TR and a TD is malformed HTML. But actually, every table in HTML is required to have a T-head element and a T-body element, and all content needs TR rows and TD cells. And so these tags are actually implicit by the TD presence. Yes. Is the number of TD elements mandated by the spec to be equal? I don't know. I think that will be purely a render side function. And this is an interesting thing about the HTML spec. The HTML spec is 500,000 words. And parsing HTML is actually just one small chunk of it. The spec involves CSS and how different properties impact rendering. It involves JavaScript and how the JavaScript should behave and interact with the page, including what happens as the page is loading and you have those script tags that run. It incorporates what they call the IDL, which is the interface description language for each tag. And if you've ever looked on MDN's HTML pages, you see things like content model, phrasing content, allowed children, and there's additional rules. And these specify what well-formed HTML means, but in a lot of cases, there's no repercussions if something breaks those violations. It's more aspirational and normative. And I think my guess is with TDs, my guess is that it's just like one of those. It's like, it'll render funny. That's a good question. And if somebody finds the answer while we're talking, then that would be great. Just another few quick examples. Something you may not anticipate is white space is fairly permissive in HTML. All white spaces, tabs, form feeds, carriage returns, and new lines. What did I say? Did I say that twice? There's space, tab, form feed, carriage return, and tab. Did I say that? I can't keep 5 things in my head. These all turn into a single space in HTML when they are inside syntax. And actually, a lot of early HTML that people were writing in a text editor would, add attributes on a new line and start each line with a space. And part of that reason is, if you had, your div tag and then you start the next line and indent the text, you end up with like a space where you don't want it. So people would do funny things and they'll, they'll put the angle bracket on the next line, and it looks kind of weird. But we often don't remember that this stuff can happen in any form. Something like this is actually the reason the HTML API became a thing. Because for years, both Adam and I had been watching this problem and not finding a solution. And then there was a series of 3 different breakages in Gutenberg that turned your site into a white screen of death. And funny enough, they were all around space. Like, there was some code that looked for a closing tag and an opening tag and used the result of that, and it didn't find it because there was a space between those tags. And when it didn't find it, the search function returned null, and then someone tried to access, item 0 or item 1 on the null, and it crashed. So like this stuff is really common. In fact, I even see new code proposed for WordPress or Gutenberg probably like once a week that that trips on stuff like this. And we do a lot of things inspecting attributes, and this is a classic problem with regular expressions. We try to get the attributes, but we fail to realize that there can be character references. And there's multiple levels of semantics going on here. We talked about syntax errors. We talked about balancing and semantic issues. But once we get into attributes, there's a whole other level of quirks that we may not anticipate. So in this example, I wanted to highlight that what CSS class or classes does this div tag have? I'll tell you, just red. Which red? All three. I don't know the answer. I know that it's just red. I don't know which red it is, but there's a caveat because it depends if the page is in quirks mode or not. So depending on that doc type tag, if you get a snippet of HTML with this, you actually don't know what it is. It's safe to assume that it's just red, in which case the class names are case insensitive. But if you get old HTML that has one of these quirks mode flags, that comes from a decade ago, it might actually have 3 different class names. And that matters for styling because the way that you write your CSS to match this will depend on how that's interpreted. There's other quirks. These are things I see a lot. Inside of certain HTML attributes, we think of them as being either one value or some set of values separated by commas or spaces. And that's a very reasonable assumption because some attributes are single values, some are comma-separated lists, some are space-separated lists. But what is this rel attribute? What rel attributes does this a tag have? You could look it up, but I'll tell you the answer in a moment. No open or no follow with a comma in between. Actually, yes, it's one attribute, or it's one value. It's no open or comma, no follow, which means every browser ignores it because rels are space separated. And I see John smiling because theme.json declares font family and font face as a string value, but font family can have multiple fonts, like your primary font, your backup backup font. And there's a mismatch in theme.json and the HTML because theme.json doesn't specify if it's one value or a comma-separated list of values. And so you can't actually know. And then, another little quirk here, just going into the attributes, is things can go deep. Like we think about images having a URL, but actually quite often images have what's called the data URI, which is an encoded form of the data right there in the tag. In fact, if you copy out of Google Docs into WordPress, you'll get this. Sometimes we have issues that crash a WordPress site because they have, a 40 megabyte image encoded in base64 in the paste. And if we don't anticipate that, we'll completely miss it. And we might screw up, or in a case like this, it's actually a performance nightmare. We can accidentally deny service to our website because we were looking to parse URLs and we ended up extracting 40 megabytes of data and we blew our memory budget. Or worse, we called WP split HTML, WP HTML split, whatever that function is, and it allocates an array, and now we have every image in the post duplicated in memory. So I hope in this initial phase of our talk, I just want to motivate and give everyone a deep sense of where this stuff came from and why it's so quirky today, what kind of things we might not think about when we're trying to parse HTML, and give you an understanding, or at least pointers, to go find more deeply what are the, like what is the space of problems that we're working in. We're going to take a break, and when we come back, we'll talk more specifically about what the HTML API can do. But before we kind of pause, did anybody want to say anything or ask a question? I know we just like blitzed through so much, but this looks like a big challenge to handle properly, but there could be like two strategies. Put the safeguards and see the limits, or let's thank you.
Let's establish the recommended markup. Like, let's go clean with WordPress and communicate it to all the users. And I think it has been like in some years, but it seems to me that now with this HTML API, uh, WordPress developers want to cover everything, all the edge cases that usual people that even do not think of, right? It's the hidden stuff that many of us just didn't know the answers, how it would result. So that's a big effort, and it's why is this? What's your motivation? Rather going to limit or support everything?
Are we going to limit what we accept, or are we going to try and support everything? Uh, my assessment is that as a platform, it's important that we do both, because we need to be able to recognize what people send our way reliably. We don't control all the HTML we get. And so it's important that we handle every edge case, because as we've learned over 20 years, and actually as the internet has learned over 40 years, making naive oversimplifications about what kind of content we can receive leads to security disasters, and it leads to corruption. So even when there's no security issue, we get corrupted data, and nobody wants that. And the internet is full of it, even among big players, Google, Facebook, like everybody screws this up. So I think it's really important that we have a solid system that knows how to look at the text, which is more or less a shortcut syntax for the structured DOM. The document object model is this data structure. It's a tree of elements and their content and their attributes. And HTML is different than that. HTML is a simplified way of describing a specific DOM tree. And it's really important for us to be able to look at an HTML document and know how to say, this is the structure it's representing. So I think it's important that we can ingest all of that, because if we don't, we will be replicating mistakes. But the whole point of this system is so that developers don't have to all know this. You in this room are now way more educated, and you've seen way more things than anybody wants to see. And so you have knowledge. But the point of building this into the platform is so you don't have to think about this in your day job. But I hope it enriches knowing. The second side of that is, even if we know how to recognize the content, if we send it along, we risk the fact that other people may be using less robust mechanisms. So we could just leave it at, we know how to recognize this and handle this. We have the opportunity to benefit the ecosystem by leaving it in a better condition than we find it. And there's a lot, I don't think we have a definitive, objectively better answer that says this is how it should be. And there's a lot of cases where we don't want to do that. But as a general sense, if we take that opportunity to normalize HTML and leave when we're saving a post to the database, for instance, if we can leave that in a more uniform and more expected shape, then we are going to lift up the whole ecosystem. And all of the weaker code, everybody using the regular expressions, everybody who thinks an attribute starts at a double quote and ends at the next double quote, that code becomes more reliable as a result of the decisions we made. And I think that's worth doing, where we can do it without grave consequences. That was a good question. Thank you for asking. Anyone else before? Okay, well, let's take a break and try and meet back here at 11:15. But we'll go ahead and get started. All right. Thanks, everyone. Was that a good time for to go and then break? Good. I'm glad it's the morning, because these things are awful after lunch. Saying, Let's take a look at what I shared. I'm going to ask everybody to have PHP available on their laptops. If anybody needs help with that, raise your hand. Maybe one of the helpers can help you out. The HTML API is available in any WordPress code, but I actually love using it outside of WordPress. And if we take a look at what is in this file, this is my way of using it outside of WordPress. And it looks verbose, but what this does is, the HTML API was written in such a way that it's mostly isolated from WordPress, and you can use it outside of WordPress, except for a few functions. And in the gist that's linked there, we have these definitions of functions that are all wrong, and you shouldn't use them in production. But this lets you write little scripts on the command line. And so what you'll need to do is, there's a path variable at the top, and wherever you have WordPress installed on your computer, you'll need to set the path. Like for me, I have it in code WordPress develop, and then there's the source directory. And the HTML API lives in WP includes HTML API, except for one, oops, except for one class that lives in WP includes. And so what would be great is if we could now make sure you download this and have PHP on your laptop, so that we can do stuff like make our font really big, call php-a, which gives us an interactive PHP shell, and then we can require load HTML API.php. And that HTML tag processor, that will give us the ability to interactively play with this. So that was a lot of steps. But step one, however you prefer to run your PHP, make sure you can call PHP. You can do it like I did it, interactively with -a, but you can also run php-r or edit a file. We can say like workshop.php and create a PHP file and require load HTML API.php. And we'll say p equals new WP HTML tag processor, var dump p next tag. Maybe a file would be great if you want to you don't want to type everything all over again, and then you run php workshop.php and it runs. The whole purpose here is to be able to run PHP and play with the HTML API, because that's what we're here for. So I'll give everyone a few minutes. Please raise your hand if you want some help. Are the instructions, do they need clarification? Yeah, yeah. Let me pull this up. If you have WordPress checked out like from the zip, like I have, let me edit this. I have the source directory in here because that's how the WordPress develop repo does it. But if you've cloned WordPress or uninstalled the zip, there's no source. It's just like the path to where WP includes is. Yeah. It's just there as an example. We're going to, but this will tell you that it works. Yes. Let's see here. Couldn't hear. What was that? Yeah, yeah. Could if you have any questions, just raise your hand and someone will come. Once you get it kind of running, just give a thumbs up so I can know when to proceed. No web server. I don't have a very complicated brain. I can't think of many things at one time, and I just run PHP. It's wonderful. Like it's so fast. It's so lightweight. Uh-huh. So you can once you have the PHP file, you just run PHP, and it'll run it and it'll finish. With interactive, it's -a, and not every version of PHP is built with this. But in that case, you get, this kind of interactive shell. Hmm. Normally we'd be writing plugin code, but since it's oftentimes very complicated to get WordPress started, this is a great way to just learn and prototype. The interactive command is PHP-A. And in this case, so let's see here, interactive PHP shell versus run a PHP file, PHP workshop.php. Yeah, so if you do the interactive shell, then what you need to do is you need to run these commands in sequence. The benefit of the interactive shell is that we can continue to just like inspect the data, inspect the functions, play and explore. The benefit of the file is that we don't get lost. We can just rerun the file. If you're like me and you use Vim, actually there's a really cool trick which you can open a, that's pretty low. You can open like the control or the colon menu and hit the bang character, the exclamation point, and run PHP and then %sign. And that puts the file you're editing in. And so like actually if we do this, it'll just run it. So that's pretty cool. I don't know if you use VS Code how to do that, but all right, thumbs ups, thumbs down. Okay, we'll have a couple more minutes. Maybe you want to. When you leave today, having seen this, you will actually be able to run WordPress this way too, which is kind of fun. PHP comes with its own built-in web server, so you can actually just run PHP in the WordPress directory and it'll serve WordPress. No, this will clear the terminal and get the output up above so that you can all see better. It's less important if the bottom of the screen weren't so low. All right, thumbs up. All right, if you're still working on it, keep working on it. Or where can we go on the playground, Adam? Well, okay. If you're still having trouble, um, and the Wi-Fi works, there's a playground option, and if you're still having trouble getting PHP running, you can attempt to load this in the browser, which is Adam's PHP plugin, which will load the HTML API for you. But, oh, sorry, I'll bring that back up. I saw the camera. Okay, back to it. So obviously, if we put HTML in here, let's start writing some code together. If you've looked at any of the material, you know that we kind of set up the HTML API on this loop, either typically a while loop or an if statement, and then either next token or next tag or something like that. Next token is going to step through every part of the document and print it out. Next tag will jump from tag to tag. And what we're going to do here, just to get started, is we're going to say echo get token name, and get modifiable text. New line. Let's see, let's change this up. So we're going to crawl through the HTML, and we're just going to print what kind of token it is. Actually, let's do this. That'll be best. We're creating a new tag processor. We're giving it HTML. We're looping over every token in the document. And we're printing out the kind of element it is. And if there is modifiable text, we're returning that modifiable text. Thumbs up? Great. So right away, we can see that WordPress is aware of this information. And if we really wanted to get kind of gnarly, we can look at all that's available. We've got get token name. We've got get attributes with prefix, which is a funny named function. We've got get modifiable text. We've got is tag closer. And if we run this again, I did something wrong. Token name is closer. Attributes text. Ooh. Get attribute names with prefix. Thankfully, this is all documented. There we go. So what information does it give us? It gives us the token name. It tells us whether or not it's a closing tag. So the first P is not a closing tag. It tells us any attribute names that it might have. And then modifiable text represents text content. That could be an HTML text node. It could actually be the contents inside of a script tag. It could be the contents inside of a style tag. Tag names will always be uppercase. And non-tag names will always start with a hash sign. So if you ever get a token name or a tag name that starts with this octothorpe character, it means it's syntax, but it's not a tag. It could be text for a text node. It could be hashtag doctype for an HTML document type declaration. It could be hashtag comment for an HTML comment. And then here's our final p tag, which is a closer. Closers have no attributes and no text. Let's just see what that looks like. Let's change this to a comment and rerun this. And now we only have a single token. Its type is a comment. It's not a closer. And its modifiable text is everything inside of the dash dash brackets. If we take a look at a script tag, the token name is script. It's not a closer. There's no attributes. And its modifiable text looks like HTML, but it isn't. It may look funny, there's no script closing tag, because the HTML API treats the entire script tag as one entire thing. In fact, if we try and parse a script tag that isn't closed, it returns nothing. That's because if the HTML API pauses in the middle of a token, then it will tell us it started to parse content, and then the document ended before it could grab an entire piece. Which means if we change this script to a div, we're actually going to get a lot of tokens. We've got the div opening tag. We've got a text node. We've got a tag named is. We've got a text node. We've got a comment. And there's no div closer, but it was able to parse complete tags. But on the other hand, if we have something that looks like the start of a tag, then it tells us it's incomplete. Red, red, red. What's that? The fun one, yes. So if we take a look at this, we see that the tag name is a div. It's not a closer. It has one attribute named class. And there's no modifiable text because it's a tag. But if we look at class, we can call getAttribute. And this is the string value of the class attribute. But we can also get the classes by calling getClassList, I think. By calling ClassList, which I think iterator to array. So this is telling us we have 3 classes, all named red, all different case variants. And just to show you what happens, if we add that doc type at the beginning of the document, HTML processor, thank you. Tag processor doesn't know this. Thank you. We'll go over this in a moment. Odd. Aha, aha, aha. So by adding the doc type, here's our token name. It's lowercase HTML special. It's not a capital HTML. It's not a capital token name, so it's not a tag. The token name here is HTML. We'll skip that because there's all these implicit tags, which we'll get back to. But here's our class attribute as red, red, red. And they still show red, red, red. Will that do it? Delete it. Okay. There we go. So we removed the doc type declaration, and now it knows there's only red. So that answers our question. I don't know these things. I'm glad the HTML API does. This is all documented. What's most important right now is that everyone is able to put some HTML in, iterate, and call these methods. So people able to do any of this. Okay. Just a moment ago, we switched from this, where we created a new tag processor, and we switched to creating an HTML processor. And the reason we had to do this was for the CSS classes. The tag processor is a very fast class for breaking apart HTML into its syntax tokens, which is like a start tag, an end tag, a text node, a doc type declaration. But it's unaware of the structure. In fact, if we come in here and we say h1 the event, h2 to be at, h2, h1, and we'll compare each of these in steps. If we load the tag processor with the example from the presentation, then as we iterate, we're going to see we've got an h1 opener and our text node, and then we've got an h2 opener and then its text node, and then an h2 closer and an h1 closer. Because it doesn't consider the DOM. It doesn't consider how the different HTML semantics map, but the HTML processor does. And there's a trade-off. The HTML tag processor is about 7 times faster than the HTML processor. And so if we create an HTML processor instance and rerun this code, it actually prints out different tag information. Let's step through it. It's got an h1 opener followed by the text node. That's the same. But whereas the tag processor next showed us this closing or this opening h2, let's see what comes next. The HTML processor says the next thing is an h1 closer. And how is that? That's because when it encountered this tag, it knew that the HTML rule is this is implicitly closing that h1. and we proceed to the H2 opener that's physically there, and then it steps into this text node, and then it gets the H2 closer that's physically there, and then the H1 doesn't exist. So the difference between the tag processor and the HTML processor is that the tag processor is literally representing the tokens in the stream of HTML as it comes. The HTML processor is interpreting those tokens and representing this normalized, idealized form of the document that we all expect. The cost of that is that it has a lot of logic that it has to perform as it approaches each token in the HTML. And I don't want to go into it now, the difference between this invocation of create fragment and create full parser, which you can see in the documentation. But the short note is that whenever we receive a snippet of HTML, we should use create fragment. And this is like 99% of all that we should ever do. If you have an entire HTML document from start to finish, then we want to use create full parser. But in WordPress, we almost never have that. So we're almost always using this create fragment. There's another subtle difference between the tag processor and the HTML processor, and that is, if you notice, the tag processor has new, and the HTML processor has a static method. That's because it's never possible for a tag processor to fail. The tag processor will get through all HTML regardless of what you give it. But the HTML processor can fail for different reasons. You may encounter encoding problems, like if you create this and it's in an encoding that WordPress doesn't support, it cannot proceed because it doesn't know how to interpret the text. And further, as we parse in this while loop, there's still about 1.5% of HTML in the wild that it's not able to parse. And what happens when that occurs is that you'll get to this point and this next token thing will return false. Well, let's just watch it. Let's go back to our example from earlier, and we'll do table, div, td, cell. So if we step through the tag processor's version of this, we see the table opening element. Let's make this a little easier to see. Echo p get token name p get modifiable text. So the tag processor sees a table opening tag, a div opening tag, a td opening tag, and a text node with cell in it. The HTML processor sees the table opening tag and nothing. And the reason is there was an error. And the error is unsupported. Hopefully, the number of cases that are unsupported goes down with time. But in a case like we looked at with the table, there could be extreme performance implications on your site if we were to try and fix this. In the browser, it's actually not that hard of a fix because it creates this DOM and it loads the entire post into memory, and it already has this, and it has to have this because the browser has to render the whole page. But on the server, we don't want to do that because that leads to out of memory on the server. On a typical WordPress installation, we may have 128 megabytes of RAM to fit the entire request. And some of these HTML documents would require a gigabyte of RAM just to parse. In your browser, you typically have 16 to 60 gigabytes of RAM to parse a single post. And on the server, we're trying to host thousands of requests per second. So these resources are constrained. So if we were to support this by default, it would mean that there are some HTML documents that could bring your server down. But it'll tell you when it encounters that unsupported HTML. You can check if there was a last error and then proceed however you want. In some cases, what this means is when we encounter an unsupported HTML, we can just proceed with the tag processor. Or we might stop parsing. If we're trying to grab an excerpt out of the post and we encounter this, maybe we just stop. We stop right there and we keep on moving. The HTML processor has this really cool function. Let's replace this with p serialized token. This is new in WordPress 7. It was there for a couple versions as a private method. Serialized token is the basis of normalize. And what it's going to do is it's going to take whatever token it's at, and it's going to print the fully normalized version. So if we go back here and we say div class equals red, ampersand hex 52 ed, class equals test, class equals 5 equals 5, and we just throw crazy garbage at it. Oh. Oh, okay. I'm going to cheat. I'm going to cheat because I need to update my load HTML API function. I'm just going to load WordPress. Load it all. It's much slower, but everything's there. So here we have 3 duplicate attributes. It looks like we have 2 duplicate attributes. Actually, we have 4 duplicate class attributes, 3 of them, and then this. And serialized token removes the duplicates in the appropriate way, and then normalizes other attributes. This is a bug. This is fixed in 7.1, but it should say equals 5, which is really weird, but that's how HTML is. And so what you can do with this is when you're processing with the HTML API, a common operation is that we're moving through the document and we're calling serialized token and building a new string. And if we encounter unsupported HTML, we've got everything kind of up to that point in the document. And if we choose to, we can move forward with the tag processor. One thing I like to do is if I get unsupported HTML, I'll switch to the tag processor and I'll only append text nodes, because I may get off on my parsing if I try and preserve the tags, but I'll at least get the content. Another legitimate option we have is when we encounter unsupported HTML, we can just stop. And let's take a look at what that looks like. How are we doing? Thumbs up, thumb down, too much, too little? I encourage you to try and code along. Actually, let's do this. Welcome to WCEU. It's great you're here. Table, div, uh-oh. another section, eggs. And what we're going to do is we're going to have a buffer and act like we're normalizing our document. By the way, this is effectively what normalize HTML is in WordPress. It steps through each token and it serializes it and appends it to the buffer. And at the very end, we're going to echo our buffer. All right. Interesting. Am I on the tag processor? No. I don't know how that worked. Thank you, John. Yeah, let's print the buffer. Live demos. They're wonderful. So here, we're stepping through with the HTML processor, and it encounters unsupported HTML, but not all is lost. We at least get to the point where we were unable to parse it. If we're clever, we could pick up where we left off with a subclass that can dump the HTML processor state into a tag processor, and we can start, but we don't have time to be clever. So what we're going to do instead is, if we get an error, we'll just clear our buffer and repeat the code. Using the tag processor. Yeah, that's going to mess up. Next token, we'll say if, and here we'll only stop on text nodes. And we'll grab the plain text form of the document. So we failed to parse it structurally, and instead we jump back to the fallback system, which just grabs the plain text. And it's not perfect, but not all is lost. In fact, character references will still be decoded. Script tags will still be ignored. My favorite emoji. So note that the script tag is gone because it's not visible text. Modifiable text is kind of like text that would be rendered in the browser. So one last thing that I'd like for you to get in your little script, like my little script, is instead of setting the HTML, what we're going to do is we're going to file get contents from standard in. And what this is going to do is when we run from the command line and pipe HTML into this, it's going to read from that input and spit it out. This is effectively turning our little script into a function that we can call from the shell. because at that point, we can do interesting things like use curl to load a website or to read a file and pipe it into our script. And here's a normalized version of WordPress.org. It's kind of a mess. But if we go down and look at the plain text version of it, let's just force that. If true, or that. We run that again. Look at that. Not great, but much better. Got a lot of white space, but we can read it. Or let's say news.ycombinator.org. No, .com. Yeah, something. Yahoo. You can really get a good idea of which web pages are accessible by doing this. Too many requests. That's interesting. So we're going to pause, but we're going to build on this loop here in the final break, and we're going to look at Markdown, and we're going to look at HTML conversion and extraction. So let's get back at 12:15. And actually, any thoughts or any questions before we break? Yes, I can show the whole script. I'll delete. That's. All right. Welcome back, everyone. We'll get started again. We have half an hour remaining, and then there's a break, and then there's lunch. And I will remain here throughout the break. If you prefer, you can remain here in the break. If everyone stays, we'll just continue going on together. If most people leave, you can come up and we can chit-chat one-on-one. During this break, a question was asked, it would be useful if there were some recipes for how to use this stuff. And if you haven't looked at the official WordPress documentation for these two classes, the tag processor and the HTML processor, I encourage you to check these out. They actually start with recipes. What is this? What is it meant for? How can I use it? And the documentation is quite extensive and designed to guide you progressively into more advanced use cases. And we've tried really hard to make valuable documentation for all of this work, every method, every class. So I hope that you find some value in it. If you get an opportunity, open this in a tab. We're going to talk about this code that's in a gist and do some fun things with it. WordPress HTML API does not support officially doing things like replacing the inner contents of HTML. I know at least one person has tried doing this, but who really wishes they could replace inner HTML? Did you know that it's possible? It's not possible in the official API, and there's a reason for that. But I'm here to tell you that you can still do it through your own minimal code. And there's multiple ways of doing this, but we're going to look at what we built up at the end of the last phase, which was stepping through the document and calling serialized token. A quick backstory. It's possible that in changing inner HTML, that we have to reinterpret what we've already parsed. An example of this is that if we have, let's say, a p tag, a p element, and we want to replace the inner contents of the p element, what happens if we set a p element inside of that p element? It's a trick question because there's no possible way in HTML to do that. In the browser, when you load HTML that has nested p tags, or if you try and load in a browser what looks like nested p tags, we already discovered that the p tag automatically closes any open p element. So what the browser will do is it will create two sibling paragraphs. It's not going to nest them. It's going to move them side by side. If you're working in JavaScript and you have already parsed the website and you're working with the DOM, the full parsed tree data structure that represents the web page, you can tell that DOM to insert content inside of an open p tag and insert a p tag. So actually in the browser, you can get nested p tags, or technically you can get nested p elements because tags don't exist in the browser. But there is no possible way to send an HTML page to a browser that will cause that browser to create the nested Ps, or the nested titles, or the nested H1s, or the nested buttons. So there's a fundamental limitation to which of those DOM trees that HTML can represent. There's a lot of different ways in HTML to represent a given DOM document, but there are certain DOM documents which cannot be represented by HTML. And this is a fundamental problem that WordPress has to wrestle with. If we want to provide a reliable interface for developers to work with HTML in a way that they share an understanding of what that document means with the browser, then this is a problem we have to solve. Coincidentally, this has become a recent topic of discussion on the HTML specification mailing list. Chrome has implemented some work already to stream HTML updates out of order. And they are discovering the same problems that we discovered a couple years ago in WordPress, which is that when we're working with the text, we're limited by these things. It doesn't mean that you can't do it. It just means that you can't do it reliably in the general sense. So let's look at this builder real quickly and see what's going on. Set inner HTML. Imagine we're working with those documents that we did right before the break, and you want to replace inner HTML. We've started with an empty text buffer, and we're progressing through each token and copying that token to that buffer by calling serialized token. And say you arrive at a node that you want to replace the inner contents of. The HTML processor will tell us when a certain element is closed. It does this through depth. In fact, let's just show that real quick. I'm going to undo this to the HTML we control, and we're going to go down, and we will do something really janky here, and we'll just add p get current depth. And hopefully, we need to close our string. Gotta figure out what I did wrong. There we go. So we have a p tag at depth 3, and then a text node at depth 4, and then a script tag at depth 4, and then a p closing tag after depth 4. And the depth represents how deep nesting is. We start at 3 because every HTML document starts with an HTML element and a body element, and then the HTML tags we get are nested inside of that body. And the way this works is that when you call next token or next tag and you enter into an element, once we reach the P, it increases the depth. So the body is at depth 2. We got the P opening tag. We're now one step deeper. That P tag will remain open until the current depth is less than 3. So if we track the numbers, 4, 4, 2. So the closing P tag brought us back into the body level. So when you open a tag, it's already increased the depth, and when you close the tag, it has already decreased the depth. They're imbalanced, and that makes it easy to do what we're looking at. So when we start, if we want to follow until that P tag is closed, all we have to do is track the depth. You know, usually I will start by grabbing the depth, and then we just keep on looping until our current depth is less than where we started. It's actually beautifully simple. So the HTML processor can tell us where elements open and close, but it doesn't provide a direct mechanism to replace the contents. But if we're building this buffer token by token, then we actually have a way to replace the contents, because once we enter that P tag and we serialize its token, we don't have to continue serializing tokens until the P tag is closed. So what that means is, this is way more complicated than it needs to be. Here's the heart of the loop. We've entered the node, we've tracked its depth, and while we're inside of that element, serialize the token. Well, I'm in the wrong function here. But we would serialize, except for in this loop. We would just skip until the end, and then we just append to our text buffer the new HTML we wanted to replace it, and we start serializing tokens again. So it's like we copy the document up until the node we want to replace, then we insert the content we want to replace it with, and we skip over those children elements, and then we start copying the document outside of it. This must be, well, this is more complicated because I actually beefed up its reliability. Let's write this ourselves. So we'll say we'll replace the contents of every p tag, which is if p is the get tag or get token name. And a fun thing about the HTML processor versus the tag processor is that we never have to check if this is an opening element, because in the HTML processor, an opening tag always precedes a closing tag because of the normalization that it does for us. We'll say if it's a p tag, we will copy it to our text buffer, and then HTML is the coolest. We'll add our own contents, and then we'll start a second loop while p next token, we've got to track the depth, and p get current depth is greater than or equal to depth. We're going to skip the existing content. And continue. And down here, buffer is just p serialize token. So we start processing the document. As soon as we reach a p tag, we go ahead and flush out its opening. We add our own insides. We just skip until it's closed, and then we continue. Actually, I don't think we want that. So let's see if it worked. And we'll get rid of the, yeah. HTML is the coolest. So we've done set inner HTML, not by directly replacing the contents, but by simply stitching two documents together. This HTML serialization builder class demonstrates the different kind of operations we can do with this. We can prepend elements, so put HTML in front of a node. So who can propose an idea? If we want to create a function that prepends HTML in front of a tag of interest, how do we do this? It's analogous to stepping through our document and serializing each token until we reach our token of interest, adding what we want to prepend, and then continuing. So we'll go back and we'll say, when we reach a p tag, what we'll do is add, let's see, what would be a fun thing? We'll add the ignored token just to be cute. And in this case, we want to see his tag closer. We don't want to put it in front of the end tag. And here we go. We've injected a tag in front of every p tag. Or if that's muddying the waters, let's say we'll add a sweat. So as you read through this HTML builder class, like we've got this wrap method. I want to wrap the contents of an element in some other tag. I want to wrap it in a div. What would this operation look like? Anyone? We want to surround every p tag with a div with a certain class. Any guesses? We find the tag of interest, we add what we want, and we wait until it closes. So in this case, it's easy because p tags can't nest. Class name equals red. And then the tricky one here is that if we want to wrap, we have to do it before or after accordingly. So we go until we find the element of interest, and before we serialize that token, we add our own prefix to the buffer, and then we go on as normal, and once we reach the closer, we add the closing. And if we weren't working with p tags, which are the easier case, we would just track the depth. We'd say like when we reach our tag of interest, we track the depth. When that depth is now lower than that, we know the element has closed, and that might even look easier. And look at what it did. It surrounded it, and there it is. Interestingly, the script is part of the p tag because the p tag apparently didn't close until the next p tag. I don't know these things. I'm glad the HTML API does. So all of these methods are actually possible. Set inner HTML, set outer HTML, get inner HTML. What would get inner HTML look like? I hope you're seeing a pattern in this. Anyone want to try on their laptops? Boom. Exactly. In this case, let's see here. In this case, we can track it, and we can say, we're not going to serialize anything until a condition starts. So like here, when we get to the p tag, we'll start copying. If we're in the process of copying, we'll serialize to our buffer. And then when we get our close condition, we'll stop copying. And this is not inner HTML, but outer HTML. So we just wrote code that extracts all of the p tags from, or p elements from the document. So maybe you want to write a function that just grabs every image element from a document. Well, you can do that with the tag processor, but if you wanted to grab every div with a certain class name, you could create that div as the starting condition, track its depth, and as soon as the depth goes out, you stop serializing. And you could even do this to put like this into an array. It doesn't have to be a text buffer. But this builder approach is incredibly useful for all sorts of these kind of operations. Thoughts on inner HTML, outer HTML? We had a question on changing tags. This is exactly how you would change a tag. You walk forward until the tag that you want. Then, instead of serializing that tag to the buffer, you put in the new tag you want. And if you want to transfer the attributes, we can actually do that by, I'll just show it here because it's easier shown than seen. What we can do is, supposing we're on a tag, then you can say for each p get attribute names with prefix, I think is what it is. New tag equals new WP HTML tag processor. New tag set attribute p get attribute name, and then buffer is going to be new tag get updated HTML. And this is a way we can transfer attributes to a new string. And there's no escaping issues. There's no security issues. There's no duplicate attributes. It'll copy it over. Well, there's a bug here, but new tag, next tag, next token. Create a new tag processor, advance into the token, set the attributes, and go on. And so here we're able to like change an image tag to a source tag. I'm sorry, why is the what? That is a great question. Why is this called get attribute names with prefix? Honestly, to be a little annoying. There's also a block processor as of WordPress 6.9, which is a lot like the HTML processor in its design, but it's for moving through blocks. And it has this other annoyingly named function called allocate and return parsed attributes. One of the principles of the HTML API and WordPress's next generation of streaming APIs is that they expose the costs of what you're doing when you do them. They are lazy. They don't eagerly do work that isn't required. And so one of the things in the HTML API is that when it parses a tag, it doesn't decode the attributes. It doesn't deduplicate the attributes. In the browser, it does. If you use DOM document, and I hope you don't, or its replacement, an actual HTML parser, the DOM HTML document, it eagerly parses the whole post. This takes a lot of time. This takes a lot of memory. The HTML processor doesn't do that. If you don't call getAttribute, it never decodes the attribute value. One thing it does do is it knows where the attributes are. And so when we call getAttributeNames with prefix, it's giving us an ability to kind of like scan through the attributes in a way that only does as much work as is required. And with the long name, it's designed to pique our curiosity so that we'll open up the documentation and see, oh, look, there is a potential performance implication for calling this function. There's another reason it's so robust. There is a common use case of iterating data attributes. And, you know, like a lot of times, we might want to loop on the attribute names, and we'll check string starts with. This doesn't totally match up the way we want to think about the structure of the document because there are some nuances in the attribute naming. And by supplying the prefix, it removes a lot of user space code that's setting up these while loops, and it's doing so in the most efficient way we can. So it's designed for iterating these things, the prefix part giving you the notion that it's actually faster to only interact with the attributes you want rather than starting by grabbing all the attributes, immediately throwing away that computation, and then working on the ones you care about. So I encourage you to go look at this class. You can actually download this class and use it. It's a very robust version of this. And one of the reasons it looks more complicated here is that if you try and insert a p tag inside of another p tag, it's going to complain. I can't remember what it does. It might refuse to do it. It might silently truncate the content that can't be there. But this was quirky experimental code, and I wanted to explore the space. What can we or should we do in order to provide this reliable interface? Before we move on to the next mini project, there's a little note about performance here. What I've shared with serialized token is going to be your simplest, most reliable method of interacting with inner and outer HTML. But there's a performance cost to normalizing all the HTML, and we don't always want that. And while we're not going to dwell on it here, because you can always reach out to me on Slack or interact online to get more detailed help, there's actually a way that you can get raw sections and just concatenate the input to the output. So I know a few people mentioned they're using bookmarks, and bookmarks exist because you can't move backward in HTML. You can only move forward because of the complications of the syntax. But if you've been at a spot and you've already parsed it, you can then return to that spot. And we use bookmarks as a way of doing that. Since string offsets are one of the most dangerous things we can pass around, the interface to the HTML is designed to hide them until you really, really, really want them. Instead, you set a bookmark with a name, and you can pass that name back to the HTML API, and it will go to the location that you were at when you did that. And this is reliable, because if you make some changes, you're going through, you update some attributes, and it's possible that in changing those attributes or changing some of the content, the bookmark shifts. A string offset would just give you broken HTML, but the bookmark will always track where it's at. Well, there's this sneaky little trick that if you happen to be in a subclass, because this is a protected method, then you can say here equals p bookmarks here, and this will return a WP HTML span object. And this span object has a start and a length property. And that start and length represents the complete token that the bookmark is tracking. My one rule for this is when we access a bookmark like this, we immediately use it and never use it again. You don't return a WP span. You don't return an offset from a WP span. You access it, use it where it's at, and forget it. And the way that looks is token equals this. Actually, that would be this. Substring this HTML, here start, here length. We use the bookmark to get the token, or we might use this to get all of the HTML before the token. Or we might use this to get all of the HTML up to the token and including the token. And why is this relevant? Because if we look at this builder approach to setting and modifying HTML structure, it can be pretty costly to normalize every token, and there may just not be a practical need to have that level of reliability in the system. And so, if your use case demands it, then you can write a subclass of the HTML processor. You can write methods that access these protected bookmarks, and you can directly copy the raw HTML input for tokens that you don't care about, insert your replacements, and continue on. And that skips the serialization step. This isn't documented. This is not in the marketing material. You know about it because you're here. And anyone who attends any of my HTML talks in the last 2 years knows about it because I've mentioned this. This is functionality that's available at your own risk. Core doesn't want to tell you what you can and can't do. The HTML API is designed to let you do what you want to do, but it's also designed to make sure that you're aware of the decisions you're making. If you use something like DOM HTML document or DOM document, you probably aren't aware of the choices you're making and the performance footguns that it draws. So a lot of these things are more cumbersome by design so that as you use this and as you grow and you become more advanced with it, then you'll find these edges that are like, oh, that's cool. It's like holding Option key in Mac and clicking. We'll skip this one. This is an interesting one to at least take a picture of and open and explore later. Now, we kind of looked at this. We didn't say we were looking at this. But in the example where we stepped forward with the HTML processor, and then when it failed, we switched over to the tag processor with plain text, we stumbled upon a pattern that's really valuable, which is parsing a document until some condition and then stopping. Even though this stuff in isolation is slower than regexes, in practice, we often have magnitude gains of performance. If you want to grab an excerpt of a post using get the excerpt, it actually starts by breaking apart the entire document into this big array where every single token is duplicated in memory, and then it starts piecing the array pieces together. But with the HTML API, we can actually walk forward until we've had, let's say, 30 words of plain text content, and then stop parsing. So we can navigate 20 kilobytes into the document and be done before another method even begins. And truncating HTML is a fun and surprisingly complicated task. And there's different ways we might think about truncating. We might truncate with HTML tags preserved, or we might truncate without HTML tags. And this is kind of like a fundamental problem we get over and over and over again. If we want to truncate to 30 words or 30 characters, 300 characters, how much do we grab out of the document? With the HTML API, we can actually step through and track things differently. We can say, step through until we have 300 characters, and only count the characters that are part of those text nodes. And in a sense, this function is really simple. But here's the main loop. We start a new HTML processor, and we start moving forward. If there's a text node, then we grab the node text, which is just some helper utility here. I don't know what it is. It's not present. This is old. That would be get modifiable text. And then this line would go away. I should update this gist. And then we call MB stringlang on it. And if the addition of this chunk would make our length greater than 300 characters, then that's our stop condition. And then we just like serialize the document up to that point. I apologize. I didn't realize this is broken code. This was like exploratory code. But it would be a good exercise when you go home or, during lunch or something, if you try and rewrite this function to make it work. And you can choose whether to serialize non-text nodes or not. And you can choose how you count your words. For example, when I write this function anymore, I use intl break iterator, which will use the Unicode functionality inside of PHP to count words. And it counts words whether it's English or Polish or Japanese or any other supported language for actually useful word counts. And the kind of final interesting thing here is this HTML to MD plugin I wrote that actually runs on WordPress.org sites. If you go to this GitHub project, there's even a prior art folder because Markdown to HTML conversion has been, or HTML to Markdown conversion has been a side passion of mine for a while because it's relatively easy to render Markdown to HTML, but it's a rather complicated question. How do you take an HTML document and produce a meaningful representation in Markdown of it? And what I think is the best possible thing that you can do to beef up your HTML API skills is to ask yourself, how do I take this HTML input and translate it into a different format? It's full of complications. So I've written HTML to Slack down. So Slack has its own Markdown variant. How do you represent an HTML document in a Slack message? I've written HTML to Markdown converters. I wrote an HTML to LinkedIn converter because LinkedIn has its own special syntax, and it doesn't support a lot of what HTML supports. I've written a few different HTML to plain text functions because you realize that, okay, if I need a single string, like you want to generate, let's say, a single line preview of an HTML document, that's different than if you want to generate a tall HTML preview. So in each of these 4 prior arts, you can look through, if GitHub allows you, and see different aspects about this problem. And in this one, we're converting HTML to plain text. And so we start with some tracking information. And what we're going to find is the same familiar loop. While next token, and while our code point count is less, so there's like character count, while we still have characters to parse, while we still have words to parse, and while we have a budget left, continue this loop. And the budget is just a really fun way to prevent denial of service. If you have a document that's like forever, you can get some pretty gnarly documents, then you can just start with a budget of, let's say, 10,000, and every time you call next token, you decrement that, and at the end of that, you say, too bad, gotta go. The budget could be time-based. We have API calls that on WordPress.com are now limited to a certain runtime. So, you call next token, but if it's been 10 milliseconds, then stop parsing and just flush out what we have to keep system throughput high. And inside of that loop, we start interpreting the HTML and translating it into Markdown. This section here is looking for the ARIA hidden attributes, because if we want to convert to plain text, anything that's supposed to be hidden probably shouldn't make it out. So we'll use, I actually create a helper utility skip element, which shows what we did before with the depth and, next token until the depth is greater than that. I have another call out to skip invisible elements. And this is exactly what we shouldn't be doing, parsing the CSS inline, but I do it. And then a big switch statement on token name that does interesting things like, let's get there. There we are. If we encounter a BR element, that's a new line. If we encounter an image element, grab its alt tag. If its alt tag is a string and non-empty, then print it out. This will really teach you which sites are accessible and which sites think that AI can generate alt text. If we get certain block elements, we can add the appropriate spacing between them. We can represent lists and headers. Here in the header list, we represent it with repeated hashtags. And there's a very complicated version of this that's kind of the sum total inside of the lib directory. I think that's pretty advanced. That incorporates every complicated thing we've talked about today and more. But what it gives us is, if we take a look at HTTPS, If we grab HTML from WordPress.org and we want to use it in the console, or we want to pass it into an AI system, this is a lot of noise. It's not readable, and the AI is going to burn its tokens. But you can actually pass output format equals MD on any WordPress.org site, and it actually will give you Markdown. And if you pipe that into a Markdown syntax highlighter, then suddenly, you can kind of read this. And not only can you, but your AI can read it. So it turns out 3 hours isn't enough time to cluster and do all these projects on our own. And I thank you for your patience with trying to figure this out. But at this point, we're going to end. And I think it's best if we just open this up to general questions and any thoughts, any challenge that you want to do and don't know how. And then we can just talk about how that could be. We are done. I think we went through the break, didn't we? So we'll take a few questions, and then if you want to stick around through lunch, I will remain here. We can talk one-on-one. Thank you all. I'm so happy to see you here, and I hope you go home and continue with the lessons. Yeah. Block processor, yes. Yeah, the block processor ended up being designed for an unrelated reason, but it was inspired by the design, and it only parses blocks, but it separates the block delimiters from the HTML content, and it actually also tracks the depth and tells you, for example, if you're freeform HTML or if you're inner HTML, but you can pair it with the HTML API. There's an unsolved problem in core for many years, which is they want to find the wrapping HTML element around inner blocks, and that's never been possible. But with the block processor, you can get to the block opening delimiter, and then if the next element is a chunk of HTML, then you can parse that, and if there's a block opener inside of there, then you actually know the wrapping tag is in that chunk. So then you just use the HTML API to step through that HTML chunk, and that's your wrapping element. And then you can change that. The block processor exposes string indices in a little more easy way because I think there's lower risk in people messing that up. So you can do those operations combining the two, and it works well because they're both streaming and efficient. So yeah. I tell you what, let's end, and if you have questions, just come up here so that nobody feels obliged to stay. Thank you all.